just because we get around.
We have two guests with us today. We have Paul and Giselle. Would you like to say hello?
Hi.
Yeah, thanks. That's very enthusiastic hello.
Yeah.
So this is square, and I'm giving you some information here. The perimeter of the square is increasing by 12 feet per second, and I start writing stuff down right away.
I do too.
dp, because otherwise I forget it. dp dt equals increasing by 12, positive 12. How fast is the diagonal changing? Well, I might as well draw in the diagonal. Oops. How fast is the diagonal changing? I'm going to call my diagonal y. How's that? dy dt. How fast is it changing? Because that's what I'm looking for. When the perimeter, P, is equal to 60 feet.
Excellent.
How's that looking so far, Giselle? That's working good for you? I'm looking for dy dt. It's the diagonal, and it's gonna, I know certainly how to find y based on x. What do you think, Giselle? What kind of equation am I gonna need here? That sounds good to me. So I'm gonna say x squared, it's a square, so they're both the same. X squared plus x squared equals y squared. Sounds good. What's the next step?
I'd say let's take the
Let's
derivative.
take the derivative. I'm actually just going to combine these first.
Oh,
X
that's
squared
a good
plus
idea.
X squared is 2x squared equals y squared. The derivative would be 4x dx dt. Maybe I'm doing this kind of fast, but you know how this works now. 2y dy dt. Giselle, is this too fast? Or that's all good?
It's fine.
It's all good? Again, I'm looking for dy dt, so I have 4. Let's see, do I know what x is?
Well, we don't, but I think we could figure it out, right?
Sure, I know the perimeter is 60, so the whole thing is 60. Divide by 4, so what's that give me? 15, does that work?
I think so,
If
since
x
it's a
is
square.
15, 30, 45, 60, that works. So x equals 15, I'm just going to fill it right in for x. dx dt,
Hold
I
on.
don't have that. I'm just going to leave a blank there.
Okay, good.
2, y, do I know what y is? I don't know what y is, but I could certainly figure it out. I hope somebody has a calculator because I'm really not going to.
Should we just call it 15 times the square root of 2?
Well, sure.
How's that?
15, right, so 15 square root of 2. Oops, where does that go? Right here. 15 square root of 2. And dy dt, do I know that? That's what I'm looking for.
Oh, no. So hold on, you're looking for dy dt, but you need dx dt, and I don't have dx dt.
Yeah, so somehow I'm going to have to find dx dt. Is there any other information that I have here that's going to somehow help me out? What do you think, Giselle? I'm actually going to erase some of this stuff. I think I'm going to need it. Board space.
Well, hold on, you haven't used your dp dt yet. You know that the perimeter is changing at a certain rate. Maybe you could use that to find
That's brilliant.
dx
Stuart.
dt. I'm just channeling Giselle. She
That's
just whispered that
that's
to me.
fabulous. What's the perimeter of a square? Well, what's the equation for it?
Oh, it's all the sides.
Okay, all the sides, so for x, I'm going to take the derivative of it because I have how the perimeter is changing. dp dt equals 4 dx dt.
I see where you're going with this, Mr. Haas.
I know dp dt is 12. For dx dt, I don't know what that is. Divide both sides, so dx dt is going to end up equaling what?
3 it is.
Terrific. I needed that to fill in over here, dx dt.
Oh, fabulous.
3. So now I have, what's this going to be?
60 times 3,
is
180.
Thanks very much. 180 divided by 2 times 15. So that's 30 square root of 2. dy dt. I'm basically done here.
There you go.
I mean, I could simplify this a little bit. This is going to be 18 over 30, or I'm sorry, 18 over 3, which is 6 over the square root of 2, but maybe you could give me now. Finally, maybe you'll give me the
I
decimal
will.
approximation that
I
was
will
looking for.
relent and give you your decimal approximation. It is approximately 4.24. And I guess we're talking feet per inch. Were those our units?
Feet per inch.
I
No,
mean
feet per inch.
feet per
Second.
second.
Thank you.
Sorry
Somebody's
about that.
paying attention.
Feet per second. Thanks,
So, Giselle,
Giselle.
I don't know, do you see what happened here at all? I mean, I knew that I was looking for dy dt, and so we used the Pythagorean theorem, but then I got to a certain point and I was like, wait a minute, I'm missing something. I don't have dx dt, so there must be some other equation. There's some information I wasn't using, perimeter. So I just said, well, what's the perimeter of this thing? I took the derivative, filled in dp dt, ended up finding dx dt, and then went back over here and just plugged it in.
Sounds good.
Do you think you can handle something like this?